let's graph this rational function. Now, your first step is to see if there will be any holes in this graph. And to do that, we need to factor the numerator and denominator and see if anything cancels out. If any factor cancels out, the zero that goes with that factor will be a hole. There will be a hole at that number. So here we go, factoring. I see a common factor of x in the numerator. If I take out that common factor, then I've got x squared minus x minus 12. There's a common factor of 3 in the denominator, and then I have x squared minus x minus 6. Now, both of these trinomials are probably factorable, so let's keep going. Okay, so I'm going to look at this trinomial. X squared would be x times x. 12. 12 is either going to be 3 times 4, or 2 times 6, or 1 times 12. I know that inner plus outer equals middle, so I'm betting on 3 times 4. Now, inner, I have 3x. Outer, I have 4x. I'm trying to get a middle of negative 1. So I need a positive 3 and a negative 4 to make negative 1. So that means positive 3, negative 4 like this. Positive 3 times negative 4 does make negative 12, so here I have factored that correctly. Now in the denominator, I've got my 3. X squared can only factor as x times x. Now 6 is either going to be 2 times 3 or 1 times 6. Again, I need the middle to be negative 1, so I'm betting on the 2 times 3. Inner plus outer must equal middle. Inner, I've got 2x. Outer, I've got 3x. So if I want a middle of negative 1, I need a positive 2 and a negative 3. Boom, boom. Okay, so it doesn't look like anything is going to cancel out, which is good news. Well, yeah. It doesn't really matter. I can handle it either way. So nothing cancels out. So that means there are no holes. So let's see, does that eliminate some choices? So right there, the fact that there are no holes, that means it's not going to be B, because I see a hole right there. Alright, so that narrows it down a little bit. Now we've got this mess. Let's find our intercepts. Let's start with X Intercept. If you want to find the X Intercept, you can set your numerator equal to 0, as long as there's no extra number on the end, like plus 5. And there wasn't, so I can just set the numerator equal to 0. So that means I have these 3 factors, so I'm going to wind up setting each of them equal to 0. So I'm going to have x equals 0, x plus 3 equals 0, and x minus 4 equals 0. So that gives me x equals 0, x equals negative 3, and x equals positive 4. So this will give me my 3 x intercepts, 0, comma 0, negative 3, comma 0, and 4, comma 0, my 3 x intercepts. So let's go ahead and graph those. Okay, so 0, comma 0, so I'm going to have an x-intercept right here. I'm going to have one at negative 3 and one at positive 4. Okay, so those are the x-intercepts. All right, it's a lot of action going on there. Now, how about the y-intercept? Okay, now I want to talk about the y-intercept. Now for the y-intercept, I can use my calculator. Show, let's hit the table function and type in the function. So I have got x to the third power minus x squared minus 12x in the numerator, and then in the denominator I've got 3 x squared minus 3x minus 18. Alright, I'm going to stay in Ask X mode. Alright, for the y-intercept, I need to put in 0 and see what I get. So 0, 0, which makes sense because if the x-intercept is here at the origin, it's also on the y-axis, so of course it was going to be the y-intercept as well. Alright, so that's it for the intercepts. Now let's talk about asymptotes. Let's talk about the vertical asymptote. The vertical asymptote will come from setting the denominator equal to 0. Now 3 cannot equal 0, so don't worry about that. But if I set x plus 2 equal to 0, and if I set x minus 3 equal to 0, that's going to give me x equals negative 2 and x equals positive 3. So I'm going to have two vertical asymptotes. So let's go ahead and graph that. Okay, come on, vertical asymptote. Oh, you know what? I think, is this still grouped? Alright, so I'm going to have a vertical asymptote at negative 2. And I have another vertical asymptote at 3. So those are my vertical asymptotes. What about the horizontal asymptote? What's going on with that? Alright, for the horizontal asymptote, you have to pay attention to the degree. I've got the degree of the top, the degree of the numerator is 3, and the degree of the denominator is 2. Alright, because x to the third power and x squared. When the degree of the numerator is more than the denominator, then there is no horizontal asymptote. So there should be none. Okay, now, however, when the degree of the numerator is 1 more than the denominator, then there is a slant asymptote. So there's no horizontal asymptote, but there is a slant asymptote, which I will call SA. Now the way we get the slant asymptote is by doing long division. Alright, but you know what? I'm not going to do that right now for this problem because I don't think I need to. I already know I have two vertical asymptotes and no horizontal asymptote. So let's look at these multiple choice options and see what I've got. So there's only one option that has two vertical asymptotes. So that's D. So it looks like it's going to be D. This one has 3 vertical asymptotes, and that's not right. And it also has a horizontal asymptote, and there's none. So this one doesn't have a horizontal asymptote, and we know there should be none. And it has the 2 vertical asymptotes. We have negative 2 and we have 3, and that's exactly what we came up with, negative 2 and 3. So D is the only possible answer based on that. Okay, and with the points that we have, those X intercepts, those even match. So we have an X intercept at negative 3, 0, and 4. So we have X intercept of negative 3, 0, and 4. So D matches up everything, so we already have enough information to know that it's going to be D. Okay, so the problem is over because this was a multiple choice question, but if you did want to, if you had to graph this by hand without multiple choice to choose from, you would need the slant asymptote. And the way you would find the slant asymptote would be by doing long division. So let's review that. So look at these first two terms. So I've got x to the third power divided by 3x squared. So if I divide those out, then I'm going to wind up with x over 3, which is the same thing as 1/3 x. So that is what I'm going to have up here. I'm going to have 1/3 x. You know what? I like to put that over the like term. So I have 1/3 x right here. So that's the first thing you do is you divide. And then you multiply. So I would take this and I would multiply it by each one of these terms. So multiplying by 1/3 is the same thing as dividing by 3. So 1/3 of 3 is 1. So this would give me x to the third power. Alright, and this would give me minus x squared. 1/3 of 18 is 6, because again I'm just dividing by 3. 18 divided by 3 is 6. So this would give me negative 6x when I did that. Okay. Now I will subtract by changing the signs. So these will all change signs. So these will cancel out completely, and this is going to leave me with negative 6x plus 0. I'm using that as a placeholder. Okay, so once again, now I start over and I divide. Okay, so I'm going to divide this by this. Well, this is already a smaller degree, so this will not go into this anymore. So that means this is my remainder. Okay, I guess I don't need the plus 0 on the end. Okay, this is a smaller degree than this, so I can't divide this anymore. So this is the answer, 1/3 x, and then I've got this remainder of plus negative 6x over 3x squared minus 3x minus 18. Alright, so that tells me that this is going to be my slant asymptote. Okay, my SA, my slant asymptote. The remainder, you don't use the remainder when you're doing slant asymptote. Okay, so 1/3 x is going to be my slant asymptote. So if I were to graph that real quick, for my slant asymptote, 1/3, let me try that again, 1/3 x. That just means the slope is 1/3. So starting from 0, see how there's, in my mind I'm thinking about y equals mx plus b. So what I have y equals 1/3 x, and then there's nothing. Alright, so that tells me that the b, the y-intercept, is 0. So I start at 0 and I go up 1, right 3. So if I went up 1 over 3, it'd be like here, up 1, right 3, up 1, right 3. So it'd be like this. And if I went down 1, left 3, down 1, left 3, down 1, left 3. So this is my slant asymptote. Okay, let's see, can I do this? Cannot make this my slant asymptote. Alright, that's pretty good. Alright, so that's what my slant asymptote is going to look like. That's my 1/3 x that I got by doing long division. Okay, now if I want the additional points that will help me graph this, I'm going to need a little bit of space. Every vertical asymptote is going to give me 4 points to graph. Okay, so remember, I have 2 vertical asymptotes. I have one vertical asymptote at -2. Okay, so I have -2. So I'm going to get 4 values out of this that I need to use. And because first I'm going to go to the left and right of that. If I went further to the left, that would be -3. If I went to the right, that would be -1. But also, if I went halfway, this would be -2.5. And this would be -1.5. So these 4 pink values are all values that I want to graph. -3, -2.5, -1.5, and -1. So I'm going to graph all those points right now. Okay, so let me use my calculator. Still have this thing in here yet. Okay, so let's do -3. Alright, so at -3, I've got 1.1. Okay, so at -3, I had the function typed into the calculator wrong. At -3, it's going to be 0. We already knew that because that was the X intercept that we found earlier. Now, how about -2.5? Okay, -2.5. Okay, so that's giving us this. Toggle it. So at -2.5, we're at, this is actually going to round to 1. So it's basically -2.5 comma 1. So right about there. Okay, what about at -1.5? Alright, that's -1.8. Alright, so at -1.5, we're at -1.8, which is very close to being -2. Alright, so it'll be right about here. Alright, and how about at -1? Alright, that's -0.8. Alright, so at -1, we're at -0.8, which will be right about here. Okay, so that's the 4 values that we get from the vertical asymptote of -2. Alright, now let's look at our other vertical asymptote. So we also had a vertical asymptote of 3. So let's do that. So this will also give us 4 values. If I go to the left, I've got 2. If I go to the right, I've got 4. 2, 3, 4. Between 2 and 3, I have 2.5. Between 3 and 4, I have 3.5. So looking at the pink values here, these are the 4 values that I'm going to need. So let's start with 2. All right, that's 1.7. So 2 comma 1.7. All right, so at 2, we're at 1.7, which is going to be right about there. How about 2.5? That's about 3. So approximately 2.5 comma 3. So here's 2.5 and here is 3. Okay, so that's pretty good. How about 3.5? That's negative 1.4. I'm rounding up. Okay, so at 3.5, I'm at negative 1.4. Should be about here. All right, so these are all the dots. Oh, 4, we already have 4 comma 0 because that's one of our X intercepts. So we have all of these points, all right? We have the 4 points from the first vertical asymptote, we have the 4 points from the second vertical asymptote, and we have our X and Y intercept right here in the middle. So these points will show us what the graph is going to do, because it is going to approach the asymptotes, including the slant asymptote. It's got to approach the slant asymptote on the left. Okay, and it's going to then approach this vertical asymptote. Okay, now here I've got points above and below the slant asymptote. So that lets me know that it's going to be passing through like this. Okay, that was pretty crooked right there, but you get the idea. And it's going to pass through these points as well and approach the slant asymptote there. Okay, so that is what the graph would really do. So if you had to graph this graph by hand, that's the process that you would have to go through, including the slant asymptote.